All right. My mic isn't doing anything. All right, everybody. Hello. I know everyone's really excited to meet everyone else, which is awesome. We will have more time for that, I promise. There's a whole social after this, and then there's a whole nother social after that. So get ready, you're gonna make lots of new friends. But I'm super excited to kind of kick off today's meetup and introduce your agenda for today. I'm Molly. I lead the PL Endres team, which does a lot of amazing engineering, research development, and product work across IPFS, Filecoin, libp2p, DRAND, a ton of amazing other Web3 protocols and primitives. Yeah! Is that for DRAND? Go DRAND. Oh, thank you. Your agenda for today, I'm going to talk a little bit about IPFS in 2022. This is just a high-level overview. I know a lot of people here are probably new to IPFS. Who are IPFS newbies who are here to learn a lot about IPFS? How it works? Okay, who are IPFS old hats who have been in the IPFS ecosystem for a while, a long time? And then, okay, 90% of people are either shy or somewhere in between. Good to know, good to know. So I'm going to talk to you a little bit about that, overview some of the use cases, a couple of spotlights on some latest progress. Then Konstantin is going to dive into how IPFS and Filecoin work, give you a full end-to-end walkthrough there. And then I believe some folks from the Fluence Labs are going to talk about the need for Web3, storage, payments, compute. It's going to be awesome, super excited. And then we're going to end with lightning talks. So all of you can be thinking about the awesome things that you want to come up here for, I think, 1 to 5 minutes, 5 minutes, demo, show off a project you're working on, building on top of Web3, on top of IPFS, Filecoin, some of the cool technologies we have here. And so we'll end with that and then go into social, lots more time to meet the other people in this room, which will be great. Cool, so my agenda for talking about IPFS in 2022, first, high-level overview for those newbies in the room. What is IPFS? What are we even doing here? Talk a little bit about IPFS case studies, the use cases for IPFS, and then talk about a couple of progress spotlights of some of the latest metrics and some of the exciting progress that's happening in the IPFS project and community. So first, the mission of IPFS is to create a resilient, upgradable, open network to preserve and grow humanity's knowledge. We're very inspired by building an internet that is resilient to all sorts of faults, that is empowering to its users and humanity, and something that we can build a foundation for our future growth and projects on top of. IPFS is aiming at making the web work peer-to-peer. That means that instead of having a central kind of client-server model like HTTP, IPFS interconnects nodes resiliently so that even when, say, a couple of nodes go offline in our wider swarm, they can still interoperate and share data between each other and continue to connect and use their applications smoothly. IPFS is built on the foundations of content addressing. That's really the core of what IPFS does. It allows you to build applications that are content addressed. You want to use this for a whole ton of reasons. We'll go into use cases in a second. But this enables the smooth way of, say, storing an NFT or building a blockchain-powered DApp, or otherwise making sure that you can resiliently address your content regardless of where it's stored in a network. IPFS aims to address a whole ton of problems in this space. This can be useful for censorship, making sure that many people in a community can host and preserve data that's useful. This can be useful for offline, local first collaboration so that all of us in this room can use Birdie and chat with each other, regardless of whether or not our cell service or internet go out. This helps avoid links breaking because you address the data by its content instead of where it's hosted. So even when data moves around a network or the original provider of data goes offline, you can still find and address that content resiliently. It has a better security model. You can validate that the thing you are fetching is the thing you meant to gather. If Facebook decides to return you a cat video that's not the cat video you thought you were linking to, kind of SOL. But with IPFS, you can validate that the CID that you meant to be retrieving matches the content that you are served back from other peer nodes, which enables all of that peer-to-peer goodness. it's more efficient. If you already have content locally that you can fetch and cache, you know that that content is there. You don't have to go back and refetch it from your central Google Drive server, which was my pain point and why I got excited about IPFS, was building all of these tools for teachers and students. And they were super inefficient because we had to load every single YouTube video in a room of 30 students over and over and over again, despite the teacher already having it cached locally on their computer at the front of the screen. And finally, they can be really useful in emerging networks. There's amazing teams like Huddle who are building video and collaboration tools that work better in communities like India schools, where they're trying to enable teachers and students to work well with each other, actually. And so this can actually be much more empowering in areas with less robust infrastructure. An example that I love for how IPFS works versus how kind of the central location-addressed model tends to work is this great example that I think comes from early days of the IPFS community, which is imagine that someone has told you to go and read a book. But they haven't told you what book it is. They've told you, by the way, you should go to the New York Public Library, Section 9, Bookcase 3, top shelf, first from the left. That's where you're going to find this book. And so you have to go all the way there, travel to New York. Maybe the library's closed. You got to wait a day. You go and you fetch it. And you look at the book and you realize, oh, wait, I had that book in my backpack the whole time. And you just didn't know because you didn't know the content of the book that you were looking for. You couldn't actually address it and identify it by what it was. You had to know where you had to go look for it. And so this IPFS enables a much more resilient model of finding content. IPFS is not really one thing. I describe it as actually a trench coat surrounding some other really amazing building blocks and protocols within Web3, namely libp2p and IPLD, which are some of the really critical, useful like other primitives that make IPFS actually work. So libp2p is the libp2p is the peer-to-peer networking stack that's used by IPFS, and also a ton of blockchains you know probably pretty well, like Filecoin, Ethereum 2, Polkadot, others. And IPLD is the content addressing module of IPFS. It's the data model by which we actually describe, in a self-describing way, all of this content addressable data. And so if you actually think about the work that's being done in the space, there's actually many layers, each of which you can use by yourself. So if you really just want future-proof, upgradable addresses, you can use multi-formats. If you want peer-to-peer networking, you can use libp2p. And you can use each of these things without using the layer above it in the stack. So it's built in kind of a modular way that fits kind of overall enabling higher and higher order use cases as you go up. I mentioned a little bit about libp2p. It's amazing. It's a growing project. If you're excited about libp2p, please come join us next week in Paris at Paris P2P. There's going to be a ton of great talks about the latest in the libp2p ecosystem. There are 6, maybe more actually, I think at this point, over 6, maybe 7 implementations of libp2p in different languages that are powering many of the different Ethereum 2 clients. It's really the networking, peer-to-peer networking library of Web3 and powers many of the amazing blockchains we know and love. And it's also itself built in a modular way so that you can pick and choose the different submodules kind of in a library-style fashion that you want to use and depend on for your own particular use case in libp2p. And IPFS uses this very, very heavily at scale with hundreds of thousands of nodes all interoperating and being peer-to-peer connected with each other at all times. IPLD is the other one that we talked about there, which is all about CIDs. If you depend on CIDs or use CIDs in your work, you maybe address your NFT via its CID, its content ID, you're using IPLD, which is really the canonical Web3 data model. Cool, so that's a little bit about what IPFS is. We're gonna dive into it more with Konstantin next. But I wanted to also give a whirlwind tour through different use cases and case studies building on top of IPFS. And there's something in this for you. If you know of someone in different categories, I'll pause and someone can raise their hand. And then if you tell me someone who's not otherwise listed on the slide that is using IPFS for that use case, I have some really awesome, shiny IPFS socks that are not on the table back there. These are new and fancy and special, and so I'll give you a pair of socks. I have 6. I know that's not very many, but keep your fingers sharp. Cool, so some case studies. There's all of these projects. You can't even read these logos. They're too tiny, building on top of IPFS, who are using it in all sorts of exciting ways to push Web3 forward, and even bring some of that Web3 goodness to lots of applications we know and love in Web 2. Some examples are actually on the IPFS and Filecoin YouTube channels. I really recommend you go and watch some of these videos. They are inspiring, they're motivating. There's just awesome teams who are building really, really cool projects. Starling is working to preserve genocide testimonials. Birdie is building a privacy-oriented, peer-to-peer, offline-first messaging app, which is fun. I have it on my phone. I would love to be your friend on Birdie, and we can chat. Audius is building one of my favorite music platforms, period. I found way more songs on this than on Spotify that I actually love and had never heard of before. Yeah, definitely, A+. And Textile is one of the earliest and most beloved members of the IPFS Web3 community, building all sorts of useful infrastructure for other developers, started kind of like from the top of the stack and has worked their way down, making IPFS and Filecoin much more easy to use and much easier to build applications with. So check out those videos. I'm going to dive through a couple of high-level use cases, starting with static assets. This is kind of like the first thing that people started using IPFS for. Really easy to take, a file or an image or something else, throw it on IPFS. Does anyone know of any tool or application that builds on top of IPFS for storing or sharing static assets? There are socks in this for you. Go for it. I don't think they build on IPFS. I don't think so. Another? Yeah? NFT.storage does store static assets. Someone, I don't have a good enough arm for this. Oh, wow. Got like 60% of the way there. Pretty good. Websites. Lots of people store their websites on IPFS. This is super useful. It means that you can kind of content address and self-host your website data. Anyone know of an awesome tool that's not listed on the slide for storing in websites? It is not. Good one. Good eye. Oh, this is going to be embarrassing. I'm just a bad thrower. Developer assets. Lots of people put developer assets on IPFS. This means that they're versioned and they're content addressed. You can see how they change over time, and you actually can dedupe between different snapshots of, say, your code as it changes over time, which is very useful. We actually, I guess I shouldn't mention examples. Does anyone know of anyone who's doing developer assets or tool chains or other things? Reddit? Radical, yeah. Radicals, I think they're technically using IPLD, but I'm going to give it to you. Oh, sorry. Another great example is Valist. Another great example is IPFS dist. We actually use IPFS for storing and distributing new versions of IPFS itself, dogfooding, so that you can fetch your new version of IPFS over IPFS, which was actually very useful for different communities in China who had trouble getting access to the latest IPFS node because of the Great Firewall. This made it much easier for them to fetch the latest version of IPFS. I guess developer assets. Would the Filecoin proofs also maybe count here? They're always using IPFS, and it's actually really critical that they're stored in IPFS for that same use case, making it accessible in areas with slightly less connected internet. IPFS archives, groups who are archiving data and putting it on IPFS. It's a very notable archive someone might have heard of. It archives something that you use all the time. Solsify. I've not heard of that one. It's an Ethereum project? Yes, yeah, totally. The Internet Archive is the one I was thinking of. It archives the internet, which is pretty useful, but tons of people who are archiving data and putting it on IPFS. I think I actually end up overlapping in this category because there's a lot of great groups. Yeah? Yeah, Slingshot is archiving not just maps data, Internet Archive, I think, yeah, a ton of open archives that are putting data there. Another great use case is for building dApps. Most Ethereum dApps are building on top of IPFS so that they can content address their front end, which means that anyone can host it instead of one central party being required to stay online and keep that content accessible. Anyone name an Ethereum dApp or some other dApp? Aave, yeah. Tons of DeFi. Oh, I only have one pair of socks left. This is gonna be. Someone said Aave. Oh, there you go. Aave's a great one. Okay, this is my last pair of socks, so yeah, last one. Large scientific data sets. This is huge. There's a ton of different groups, and there's a lot of ones listed on this slide, so you're not allowed to say any of those, who are putting their data up here. This could be for many different reasons. One reason that I thought was an awesome example was maybe you want to use your scientific data in future court cases. You want to refer to data 5, 10, 15 years in the future and reference back what that data was and be able to prove that the data that you say time-stamped into Ethereum or Bitcoin or whatever blockchain is the same data that you're now bringing into a court of law and using to say, talk about climate change. And so these are really valuable use cases where you might put large scientific data on a cheaper platform. I see your hand, I'm gonna call on you. Where you might have large data that you wanna store on a cheap network, like Filecoin, or data that you wanna be content addressed, where you wanna be able to prove and validate and verify that data is what it says it was, and it's been proved over time to be correct and not changed. Anyways.
There is a 15 terabyte archive of Syrian war crimes that's being put on IPFS.
That is the best pair of socks example of making sure that we don't lose or otherwise have that censored from the internet and our collective knowledge and history. And unfortunately out of socks, so no more examples. But as you can see, many, many great examples, many that were not listed as well, of projects that are building on top of these foundations in these different use case areas. To run through a couple of more areas, scientific papers. I think LibGen was the one I was thinking of to put here if I only had more pairs of socks. People who are putting open access data on top of resilient content addressing foundations that can be hosted by anyone in any area of the world. Music, we mentioned Audius earlier. Highly recommend it. If you have a mobile phone, you can download Audius and use it for all of your music needs. It's really fun. I can share some favorite song recommendations with you. Video, tons of people are using IPFS and Filecoin for video. Video is large. When you want to store lots of video and you want to maybe share it peer-to-peer in an offline setting, it's really useful to have some of the Web3 primitives enabling that peer-to-peer sharing and that longer-term persistence in kind of cheap long-term storage. Some examples of groups who are doing this. VideoCoin, LivePeer, Huddle01, there's tons of amazing groups doing this and need for more. There are more groups and more tools needed here in the video use case to start making video NFTs a real thing and start like really ramping up this use case for Web3. I think it's very fertile ground. Photos, of course, many people are putting photos on IPFS today, specifically a lot of NFTs. I think we're over 50 million, probably close to 70 million, because the last time that I checked was like 3 weeks ago, and it's growing really, really quickly. NFTs that are stored on IPFS and Filecoin, which is awesome, and tons of groups that are building richer and larger and more immersive and more creative NFTs. So there's all sorts of opportunities to build new kinds of NFTs. A great example being the folks at Mona who are building even more like awesome immersive metaverse interactive and interconnectable NFT worlds that you can then buy and own these spaces. I bet you in 3 to 5 years, we're gonna be doing these meetups in Mona metaverse spaces built on IPFS, which is gonna be so cool. And so we'll get to experience a real metaverse, not a metaverse owned by Meta, that we can actually use and build on top of and has good primitives at the baseline. As we mentioned, tons of virtual world data. This is large. There's a lot. I don't know if anyone has built VR worlds here, but man, do these files get very, very large. So it's also useful to have good long-term storage and the ability to bring NFTs into different virtual worlds. So the ability to interoperate between virtual worlds and have a global addressing space where you can talk about data and reference it between different created spaces is super, super useful. So some of the content addressing primitives of IPLD make a big difference there. So yeah, lots of opportunity to store these virtual worlds on IPFS and Filecoin, make them more interactive, building games and game assets. There are a lot of amazing groups like Gala Games and others who are pushing forward in this area. And yeah, like the building blocks are there. We have NFTs, we have games, we have metaverses. Like let's go build it. There's a lot of cool work happening here. So if you're excited in this area, I would love to chat with you later. Cool, to just progress spotlight a couple of things before I hand it off to Konstantin. There's some amazing, amazing work being done across the IPFS community. I wanted to highlight 2 exciting things from the metrics that I've been tracking for a long time. One is there's just a ton of growth happening in the IPFS network. Content discovery in IPFS is getting faster and faster. This was my shtick back in 2020 was all about trying to make the IPFS DHT faster to find content in. At the time, I think we started out at something like like over 30 seconds at the beginning of 2020 to find content, which was infeasible. It was like not working. We spent a lot of focus. Within less than 6 months, we were able to bring that down to 3 seconds. Now we're down to about half a second. So that's a significant progress rate. So we, did 40x there. Now we're 6x versus where we were, and this is 2x faster just since the beginning of this year. So significant progress is being made thanks to a lot of the work that network infra teams are doing to help accelerate and speed up content discovery in the IPFS network. There's also a ton of growth in nodes in the IPFS network, really thanks to lots of new ways to run and host an IPFS node. One that I wanted to shout out is Brave's embedded IPFS node. If you're not already using Brave, I highly recommend it. It's an awesome browser. But there's also this added bonus of getting to run your own IPFS node embedded in the browser. And this lets you load your IPFS.io website directly using IPFS or IPNS:// which is super cool and super exciting to see the browser layer building kind of the future upgrade trajectory into Web3. And there's a lot of work with other browser vendors to add this additional level of support. So IPFS Companion extension is already supported in almost all browsers. IPFS handling, I guess, is already supported in Brave and Opera, and support coming soon to Chromium and all other Chromium-based browsers, which is really awesome, and thanks to the hard work that Agalia has been doing in the space. And then we already have a full node embedded in Brave, and now the question is which one of these amazing browsers is going to be the next one to integrate a full embedded IPFS node that gives users all of that kind of like ownership, ability to host and store data, and interface with the web, peer-to-peer and content addressed. There is also, just to highlight this browser upgrade path that Juan has been maintaining for a long time. We've made a ton of progress, a ton faster than we could have expected. But there's significant areas for future improvement, especially around mobile and mobile browsers and mobile OSs. And so there's a lot of work being done there right now as well to ramp up better support for IPFS on mobile. One of the kind of useful things here as well is as we have more and more browser nodes, it becomes more important to make sure that any node anywhere in the network can dial and connect to any other node. So there's been a ton of work happening over the past more than a year on libp2p hole punching, making sure that you can hole punch through NATs and firewalls in order to dial a node that's, maybe on the Ondas Wi-Fi like we are right now and fetch content that it's trying to host to the IPFS network. And this has now rolled out in the most recent version of, I think, the most recent version of IPFS now has hole punching turned on, which means that we can do signaling. There's a great blog post on the IPFS blog that describes all of the work that's been done and why and how this makes things so much better. And so definitely recommend checking that out and or getting involved if you're excited about libp2p and helping all nodes anywhere in the world be connected. The other progress spotlight I wanted to highlight was usage of things like IPFS gateways and accessing IPFS content over things like HTTP. This has been a massive area of growth and explosion. Really thanks a lot to the growth and explosion around NFTs and their heavy usage of IPFS, not on IPFS, not your NFT. So IPFS gateway usage up over 8x in the past year, which is awesome. That's really just looking at the IPFS.io gateway. There's actually many gateways being run by many other parties, and they're all getting 500 million plus. Yeah, this is up 500 million requests per week in the past 6 months, just one gateway in that network. So we're all starting to run pretty serious infrastructure when it comes to supporting Web3 adoption and usage and growth in this space. So like big snaps and hats off to everyone who is running infrastructure in order to support this level of increased usage and growth. And so, just a fraction of all IPFS users over NFT is actually, or over HTTP is pictured here. There's also a lot of work that's, this is a snapshot into a couple of the different sites, Magic Eden, PaintSwap, I know Bored Apes is on there, a lot of other groups that are building their marketplaces on top of IPFS, which is awesome. One really useful thing that's has come both to the IPFS network and to gateways in terms of making data more accessible is improving the IPFS and Filecoin indexing, discovery, and interop of content. This can be really useful for IPFS nodes in general so that they can utilize indexer nodes that want to host and and kind of index into the content that their node is hosting. That helps reduce a whole ton of kind of like annoying maintenance burden when it comes to interacting with the IPFS DHT. There's also been a ton of work happening around delegated content routing to enable many different groups to plug in different forms of finding content, different algorithms, different strategies for scaling content discovery in IPFS. And this also brings kind of new capabilities to IPFS as well in terms of offloading large chunks of static data to Filecoin so that they can focus on just hosting hot caches of data and have all of that data being indexed and accessible to other nodes in the IPFS network. I think this is actually recently rolled out to all Filecoin storage providers to be indexing their content and making it accessible to nodes that are querying it from IPFS. And so it's default as of the most recent Lotus release. And there's a lot of bridging being done to make sure that these two networks smoothly connect with each other. Really, every Filecoin node is an IPFS node. We just need to make sure they're talking the same data transfer protocols. And so there's a lot of exciting work being done there so that everyone who's building and storing really useful archives and data sets on Filecoin can also build amazing IPFS front ends that say operate over all of the map data or internet archive data or video data that's being stored there. And so a lot of amazing work being done by the Bedrock team. If you also want to get involved, this delegated content routing support is in the works and is a very useful opportunity for many people who want to maybe build their own content routing strategy and use that within their own kind of subnetwork of IPFS, or even make this something that all IPFS nodes can support and benchmark and validate that it's an improvement upon our current content routing strategies. And so definitely an opportunity for many folks to get involved if we have some builders in the house that want to start trying to utilize that API to push things forward. So that's my overview and my spotlights. I'm really excited for the next time we chat. In the meantime, ways that you can stay connected: follow us on YouTube and Twitter. Join the IPFS Discord. There's a growing, thriving community on Discord. I'd highly recommend getting involved. I hang out there all the time. Definitely subscribe to the IPFS Weekly newsletter. It has a great index of all of the cool new projects that are being created. And come to upcoming events like Paris P2P that's happening next weekend. And speaking of upcoming events, early preview, we're actually going to be hosting IPFS Camp 2022 here in Amsterdam in July. We did the last one of these, I think, in 2019, so it's been too long, darn you, COVID. And really, really excited to get the IPFS community back together and have a ton of talks and presentations and workshops from all of the amazing groups that are pushing the network forward, building on top of it, have good strategies or infrastructure that other groups can learn from and build on. So yeah, thank you all so much. Feel free to connect with me on Twitter. I'm momac28. And yeah, we'll turn it over to Konstantin for what's next.
Hello everyone, also from my side. What a great bar from Molly was rising to the presentation. I'm Konstantin Tkachuk. I'm a startup operator at Protocol Labs, and I will go you through more details about IPFS and Filecoin, and how they shape the future Web3. So today's agenda from my side would be, first of all, the core concepts of IPFS and Filecoin. Then I will talk in details about the tool for builders. We've already seen a great presentation on what are the opportunities building with Filecoin, and I will give you the exact tools which you can use straight away to make your solution better using distributed technology and IPFS and Filecoin. And then I will tell you also a bit of the highlights, what to build, what is coming in Web3, and what's the most hot topic right now. So starting with the core concepts of IPFS and Filecoin, yeah, so we are somewhere between Web 2 and Web 3. And what exactly Web 3 is? Let's suffice that it's the evolution of the internet, it's the next step of the internet, and it makes web read, write, and trust. Trust being an operative thing here, and it is achieved through a verifiability and a whole bunch of underlying primitives and technology that builds up to that. So verifiable data is essential to a truly distributed system. And data as itself is one of the big pieces of Web3 stack puzzle, which comes on a slide here. There is a lot to be updated. Development in Web3 is just immense right now. There is a lot of new technologies coming up. There is a lot of solutions coming to the Web3 stack, but still the storage itself is one of the core points of any operation happening on Web3. And IPFS and Filecoin is here to also support building or transitioning from Web 2 to a more resilient, accessible, scalable, and also cheap internet storage, and not only storage, but generally internet operation that we have. So also, I would say that IPFS and Filecoin is here not only for storage anymore, we are also building the Web3 architecture, which surely will support very soon the layer 1 blockchain coming with an FVM, and we also can easily put ourselves into the part with off-chain storage, which is also what IPFS can do. And coming from this, more of an overview, we are truly right now in this transition from Web 2 to Web 3, and some of the companies are more to the left, some of the companies are more to the right, but what we are all aiming for is a truly distributed internet, where the data, information, and knowledge, first of all, there are a couple of most important assets which we have today, and we want to preserve them. We want really to have them in the hands of people. So how to do this, how to build this resilient, and how to make sure that we actually own the data and it's not centralized and not blocked from us and not used on our behalf. That's the topic of the presentation which I'll go through right now. So if we are aiming for distributed data, we want to have a solution, first of all, which is resilient, which is performant, which is scalable. At the same time, it should be secure, efficient, trustlessness, and it should be censorship resistant. Nowadays, we see a lot of the failure points in the existing centralized solution where, while having a single point of failure, it immediately leads us to the problems like censorship, governmental, organizational, and there is no, and the data, which apparently we should own by ourselves, is monetized by the companies which have the access to it or the central access and monitoring to it. Instead of that, we actually want to have a user-powered service which ensures that we have privacy of our own data, and at the same time, the data has to be self-verified and non-siloed. So in the next 25 minutes, I will tell you in details about what IPFS, peer-to-peer hypermedia protocol for content addressing, and what is Filecoin, the world's largest decentralized storage network, and how they're working together to bring this distributed internet of Web3. And also, I will tell you that file and folders are not something boring, and they're a really exciting topic to work on. So first of all, IPFS. IPFS stands for Interplanetary File System. Let's break it down in two parts. So first of all, files and systems. These are files and folders which you traditionally operate on your computer. File could contain any content, and essentially folder is also just a table of the content inside with the files. So why interplanetary though? Because it was conceived as a way to upgrade the web in a way that it would still work if our network stretches across planets. The idea behind is that if you are on Mars and you are wishing to take some data from Earth, it will take at least 1 hour to request the information down to Earth and backwards. Instead, if you have content hashed on the Mars already, then you don't need to call the Earth anymore. You just retrieve it from the nearest node on Mars, and that's how IPFS works. It allows you to retrieve the content from the nearest node, and from the cache solution, all across the IPFS network instead of just referring to the central point somewhere on the database on Earth. And that's very handy. In order to implement that, we have to do the content addressing, which is IPFS really addresses the content by what it is instead of where it is. Molly already gave you a brief explanation, but if you think about content addressing as it is, right now in computers we do it all the time. We have a path, we have structure of folders, and we get an index of a certain item. We replace it with a content identifier. Instead of asking where the content is locating, we don't need to go to a library and then just say, okay, I need the location of the book. We really go for the book itself, for the content. Here, we give you a content identifier, which is a unique fingerprint of what you are looking for, and it tells you what you are looking for. And it tells also the network what you're looking for, and the network itself resolves the best location to serve it from, either your backpack or the nearest library or the Amazon shop. It doesn't matter for us, you can serve it from anywhere, but we give you the opportunity to discover the objects regardless of their location. And that's how we do the CAD itself. CAD in itself is a cryptographic hash function, which is SHA-256, which allows you to encrypt any object into a string, which gives you a unique identifier. And the same content always resolve you the same CID, and the content CID can be reproduced at any time from the original content. This gives us this layer of verifiability. When you retrieve a file, you can also provide a hash of it once more, and then validate if the object you received is matching the hash you originally requested. And that brings us a lot of functionality to making the web really secured in the way that we can receive the objects which we are actually interested in. Also, the CID provides us the opportunity to encrypt it on your level, so there is no secret source behind the IPFS which actually specifies how to encrypt a certain files. No, that's actually happening on your side, on the user side. So regardless of the computer where the file is being encrypted, it's always returning you the same CID, which is based exactly on your content. And that's the beauty of it. If you think about not the files, but the folders, it's doing exactly the same thing. So a folder is just a special kind of a file which lists other files inside of it. And the core principle remains the same. You can create a CID out of your folder, and it will be pointing to exact number of the files or exact list of the files which you have inside. And at the same time, the files inside could also be the CIDs themselves, so that we reduce the number of overall stored files on the internet, and at the same time deduplicate the need for storing immense amount of data. Let me briefly explain you how it works in life. So on the bottom line, we have multiple objects, each of which having their own CIDs. You see the fingerprint, and the colors are explaining the uniqueness of the CID. So we have a root CID of a folder which contains multiple files uploaded by different users. Here, the benefit of Merkle DAGs, or direct acrylic graphs, coming into the help. They are helping us to create a graph data structure in which each node is content addressed. So we exactly know what are the objects inside of each element, and we can traverse the graph to receive a certain point or an object inside the IPFS first file, then folders and folders and folders. The beauty of it comes when a user wants to create a new folder with a list of files, part of which were already existing in the network before. So you see a new user on the very right, which creates a folder which contains only 2 objects out of all 4. He creates a folder which points to the same objects, but since we are pointing to CIDs, the files are already on the network, and then it just creates a new pointers, but the object could be already stored, could be already served from the IPFS network. Therefore, it reduces the redundancy of uploading many of the same type of objects, and you can retrieve it at any point of time straight away from the IPFS network, from the closest peer which contains and has your data. So this is how CID working. It also provides you opportunity to deduplicate the files on the network and verify the content if the CID is changing. This is how one folder works. Then we go to the network itself. First of all, we need to understand that there are multiple of peers on the peer-to-peer network, which stores pieces of your data, pieces of the content, and allows you to retrieve it from the closest CID, closest peer which has your content. So we have a huge swarm, a network of peers, and for each peer, it's very important that it has to be first discoverable, and it must be routable. So we need to know how to reach each and every peer in the network, so that whenever you are looking for a content, you can really point to the certain peer and request the data from it. That's where the content routing distributed hash tables comes in place. The distributed hash tables is maintained by multiple peers, but it's only a small number of rows which are stored within each peer, and those are maintained not for the whole network itself, but more a piece is a fragmented part of it, which allows to reduce the load on each particular node. And we have a very simple two-column table which provides us with a key and a value stored, and this you can think of as a phone book, but the phone book where everyone maintains it together. So you have a name and you have a number of a person. And it's very nice because also a number in itself, you can really call it directly, which is partially how CID works, because you really address it to the person who stores your data, not to a server which knows where the person is located. And IPFS works exactly on the same way, where when you request the data from this DHT table, the peer which you requested it from either can serve the data directly to you from his storage, or if he doesn't know where the data is located, then he can ask nearby peers asking if you have the same data which my user requested. And we also know approximately where the closest peer which can serve you the data is located, so that we don't need to go through the whole swarm of the network. We rather just request the points or the peers which are more likely to have your data than the other one. And in this case, peers are maintaining the DHT table and declaring where the peer ID, which provides a specific CID, and how to connect to these peers. So then peers all the time can query the DHT table to find which peer is providing which content. So this is how the IPFS works. This is how the swarm and the network works. But what does it bring to the actual users of the IPFS network? So using IPFS in the wild, first of all, obviously you can run your own node. Then you can request the data from your node and make it available over the IPFS network. But if you're far from the node, then it will not be very reliable, or it will be long to retrieve, and so on. So then you can maybe run your own network of the nodes, and then the infrastructure and the team to support building this network. Or you can pay a pinning service to pin your content on their nodes, such solutions as Pinata, Temporal, and Fura, and many more. And then you just hope that your content becomes popular enough that other nodes will pin it. So does that sound to you as a really decentralized and reliable web? To me, not really. You really should not rely on someone's good faith in order to store your data. And that's exactly where Filecoin comes in place. Filecoin incentivizes persistence and verifiable storage designed for Web3. Filecoin uses the same process as IPFS for resultant content identifiers on Filecoin, and these are exactly the same CIDs we just talked about. Moreover, IPFS is a storage layer agnostic, and that's because the magic of IPFS CIDs, they becoming the property of the data itself, so that regardless of what solution do you want to use for permanence of your data, whether it will be a Filecoin or a cloud solution, or maybe both, or any amount of solutions which you want to develop, we still provide you the same content identifier, which is independent of us even, so that regardless what's happening for the future, we still can detect or trace the content by, trace the data by its content. In fact, Filecoin network is based on time-limited deals which allow you to store the data. So whenever you put an object or an IPFS object to the Filecoin deal, you make a deal with a storage provider to store your content and ensure cryptographically that your content is persistent and available through the time of the deal on the network. It gives you this reliability and verifiability of the content persistence over a long time, and makes sure that your content is stored redundantly and verified by network via proof of replication, which proves the storage provider is storing a unique copy of original data, and proof of space-time, which proves that data is stored continuously over time. We run checks for each data every 24 hours, which guarantees us and guarantees the final user that his content is persistent. We really run it also redundantly, so regardless if one content provider or storage provider is losing your data for some of the reasons, we still have redundant copies on the network which will be able to serve you and replicate again to the minimum required amount. For most of our solutions, we use at least 5 redundant copies so that your data is always secure with IPFS and Filecoin, and you really can retrieve it whenever you want. And that's where I can say that IPFS is really loving Filecoin. IPFS here is for fast and flexible retrieval with the gateways, local nodes, and browsers. And Filecoin is for the persistence and verifiability. It's actually amazing components and working together. And Filecoin really commoditizes the storage, which is an IPFS complement. This is like, for me, milk and cereal, or ink to printers, or storage to IPFS. Now, I'm happy to give you a little bit of a highlight for the tools for builders. And let's start with Web3 enabled architecture. We really want to have a solution which is not dependent on one centralized approach or one centralized logic. Therefore, there is a lot of different layers that serve different functions. We have, first of all, the front-end layer, which could be Web 2, existing solutions you already know. It could be also a Web3 layer. Then we have a logic, which multiple of the smart contract networks or layer 1 solution networks already have. And that's where also we'll be able soon to place Filecoin with the smart contracts and a VM coming. And then we have a storage helpers. Storage helpers serve you with a handy tools which allow you to do the Filecoin dealing and storage on IPFS network with an ease. And that's what our advice generally is, to use the storage helpers directly so that for your applications it's very handy and simple to operate the IPFS and Filecoin networks. So what are some of the storage networks or storage helpers that can give you the opportunity to build on top of IPFS and Filecoin? First of all, there is a Web3 storage solution. It's designed for Filecoin and IPFS storage. It's familiar and it has familiar and simple interfaces, and it's a production level storage and retrieval, which provides you with the retrieval reliability and performance. It's very simple to use. There is only an API key which you need to generate from registering on the website, and then you can call the API key and store all your data from your traditional web solutions on IPFS and Filecoin. We also provide, this is also provided from Protocol Labs directly, so we provide 1 terabyte always for free, and then it's possible to extend it for your specific solutions, and we're more than happy to support you developing on Web3 storage. Then one of the subset or a specific tool which was also developed for the NFTs directly, which is NFT.storage. We treat NFTs as a public good which should be available for people all the time. Therefore, this particular solution is completely free, and it's very, very easy to use so that artists, developers, and creators of all kinds on the web have a handy tool with almost no code to update from their content, so that their content, whatever they create, is reliably and redundantly stored on the web. Therefore, NFT.storage provides you the same opportunity to use IPFS to store your data, and it provides you the unique CIDs which you can store on chain and use as the pointer to the content which you have created. And that becomes very handy when you think about NFTs in the long term. This tool really allows you to not only rely on someone's storage provider, but really have a persistency of your content and not rot the links which you have on the NFTs, which points to the data you created. There is also a Fleek hosting solution. It allows you to have a fast, modern, and censorship-proof websites and web apps on the open web. It really builds on top of IPFS and Filecoin, where you can host your particular solution or your website on IPFS nodes, and it will be served to you directly from web browser, Brave, or a solution like this. It also is very easy to implement in your code. You can just connect it to your GitHub repository, add the build settings, and deploy your site on IPFS. It's also backed by the Filecoin, which is a redundant solution, and it really provides you the opportunity to make sure that your content, your website is available whenever you need it. One other solution which I want to talk with you about is the Power Gate, which provides you more functionality than dot storage solutions, and which gives you the powerful ways to connect and extend libp2p solution, IPFS, and Filecoin. It bridges near, and more networks are coming soon, and it allows you to wrap the Docker container around IPFS and file code and use for your particular applications. And the last topic I want to touch with you today is what to build. And believe me or not, there is a lot of things which you can build in Web3. We're just on the very beginning of the Web3, and there are lots of opportunities in which you can develop projects with IPFS and Filecoin. There are common 5 major points which people can focus or break down the development in the Web3 right now. First of all, you can definitely develop user and client interfaces. You can also work on smart contracts. You can develop the compute and consensus layer. And there is also a lot of opportunities on developing the hardware and networking solutions. If you're building with us or generally building in Web3, there is no need only to build apps. There is really this amount of opportunities to build your part of the Web3 and join this network of amazing developers and amazing opportunities coming all together. Filecoin, in this sense, creates a whole new economy with lots of opportunities to create your venture at every layer. And we support developers and builders from across the world on different scales, from a startup, from a small code development, to really startups on a high level, from investing from seed to Series D levels. And we are happy to promote and ensure that you're happy building with us and that you have all the tools and resources which help you building with IPFS and Filecoin. Therefore, we are more than happy to welcome you in our ecosystem. We have Discord, Slack available to you at all the time. Find us on IPFS, on Filecoin, and visit our amazing hackathons and other events. There was a highlight of all the events. We also run a tremendous number of hackathons each year. So you can not only build something right now, straight away on your spare time, but you can also participate in awesome events. There is an ETH Amsterdam coming later this week, where will be a lot of events also coming from our side, and we are more than happy to see you on different events and support you building with IPFS and Filecoin. That was a pleasure to have you here today, and that would be the end of my side, and thank you a lot for your attention.
Great. Hello. Hey, everyone. Thanks for having me. Great to be here. My name is Tom Trowbridge. I'm speaking about Fluence, but really first about the need for Web3, storage, payments, and compute. But first, I want to thank the IPFS community, the Filecoin community, Juan in particular, but everybody for having us and partnering with us. It's a terrific ecosystem to be a part of. We think that there's nothing more important than storage as one of the foundational kind of critical components of Web3. And so I'm going to talk about two other components, obviously, particularly compute. But without storage, none of this happens, none of this works. So I'm thrilled to see this group here and for us to be a part of this community. So my name is Tom Trowbridge. I'm co-founder of Fluence Labs. I helped put together Hedera Hashgraph earlier and have been in this space for a while. Look forward to kind of digging into this a little bit. And I'm going to start off by talking higher level about kind of big tech and censorship, and then going to go into a bit more about how compute is a critical piece of the Web3 ecosystem and in conjunction with storage and payments. And then from there, a little bit more detail about how that compute actually works and how Fluence architecture is a complement to storage and how it actually works and can create a powerful ecosystem. So first, in terms of censorship, big tech is really becoming an arm of governments. And that shouldn't be super surprising because every single industry, the larger it gets, governments have to interact with it, and those businesses need to interact with governments. And so you can see governments coming down really hard, particularly in, there's lots of examples in Russia censoring Google, censoring YouTube. That you sort of expect from totalitarian governments, right? That has happened in China. This is not new. You've seen it in a variety of other markets as well. But you don't pay as much attention to it until recently, that censorship not being just driven by totalitarian governments, but also by democracies. India was one of the first examples where this was really clear, where the Indian government forced WhatsApp to deplatform effectively opposition politicians and actually stop a whole variety of messaging around a variety of protests that farmers were doing. And that's an obvious, explicit democratic government exerting its influence through single points of contact with huge user bases. They were very easy to do because they're Web 2 and can be pressured, given shareholders, given jail potential for employees, et cetera. A more recent example is, Twitter blocking the post-Hunter Biden story, which we now find out was actually real, and they didn't allow any discussion of that. There's a whole number of COVID-related elements, too, that now seem true that Twitter didn't allow discussion of as well. So whether that was explicit government discussion or just censorship from implied censorship is a little bit unclear, but the point is you've got these big platforms that people rely on that have vulnerabilities of censorship. But besides that, you also have the hosting element that happens, the hosting component of big tech. And when you have hosting dominated by a handful of large companies, that leads to a whole number of potential issues regarding not just censorship, but also pricing and also innovation stifling. And so the top three hosting companies control about 60% of the cloud, and they're growing at 50% a year. And they're incredibly large, powerful businesses. And so they're driving the returns of these companies. And why is that the case? It's because they're hard to leave. And they perform a very good service when you're small. They give you a lot of technology to actually accelerate the development of your applications and your businesses early on. But then you're unable to leave very easily afterwards. A couple companies have famously been able to extract themselves from these platforms, but only a couple. And when they've done it, it's been expensive and it's taken a lot of time. Example is that Lyft alleged, this is a couple years old, but pays at least 14 cents a ride to AWS. You also have an example of Parler. Let's leave politics aside for a second, but you've got a social media platform with 2 million users deplatformed for a term of service violation. And no one here, I don't think, is going to, die on Parler's kind of social good, right? But at the same time, you got to realize that provides real warning to other groups on that platform about how quickly they can be taken off with effectively arbitrarily. And that's what happens when you have private companies in control of this. They can pull the switch on you, and even if you haven't violated TOS, by the time you've fought that out, your business is seriously jeopardized if it's still alive. And resilience, and you make those trade-offs. If you have incredible resilience, that's maybe some reasonable. That might be a reasonable trade-off to some extent. But the larger these businesses get, the more complex they are, and the more the resilience has been threatened. And so we've seen Amazon Cloud go down, we've seen Facebook go down, we've seen WhatsApp go down. All of these businesses have suffered serious outages, and they haven't gotten less as they've gotten this more infrequent as the businesses have scaled. They've gotten more frequent. And we don't expect this to stop. These are hard to run. They're complex businesses. There's incredible different single points of failure, multiple single points of failure given geographies and data centers involved. And human error comes into play regularly with almost all of these outages. And so besides having censorship, you have resilience issues, which we're supposed to be going in the other direction and being more resilient as technology advances. And the question I think everyone here knows the answer to, but I'll ask it rhetorically, is this the internet we signed up for? And I don't think so. And Tim Berners-Lee did not have this in mind when he created, basically the hyperlink and the easy access to information that we all take for granted now on the World Wide Web. But the issue is that internet economics rewards scale. And that was something not easily foreseen by everybody initially, but the scale that a global platform can catalyze leads to ever-increasing common oligopolist potential, where the larger you are, the more you can spend on advertising, the more you can spend on infrastructure, the more you can attract people, and that then allows you to outcompete the second biggest, and that kind of flywheel keeps going. And that's why we've gotten to the place of the Amazons and the Googles and the Facebooks and you name the providers, the Microsofts, right? And so that continues, and because they're so large, they also, as I mentioned earlier, have to have relationships with governments. There's no large industry in the world that doesn't have a very close relationship with governments. Both need to. And so that also is not going to go away. It's only going to continue, and the question is only to how much. And so that is the real question. So how did we get here, and how do we evolve beyond this? Because governments are just sort of dipping their toes in this. They're extreme potentially in places like Russia and China, but the US, it's only going to increase, and we probably don't even know the level of actual involvement and relationship between these companies right now, and it probably is only going to continue. So we started off with mainframes and desktops, right? That was Web 1.0. And then kicking and screaming, people were pulled into cloud computing. And I remember very well back, I was looking at and was even investing in some of these cloud providers back in the 90s, and people were like, I'd rather host it internally. I'd rather have more control over my data. It's cheaper. It's more resilient. Well, fast forward now, all those reasons that people wanted to host internally are why they're at the cloud. But those exact reasons are why we think people are all going to move to peer-to-peer platforms, because peer-to-peer will be more resilient, it'll be cheaper, and it will be less, it'll be censorship resistant. And so that's why we think open peer-to-peer networks are the future. There are no centralized bottlenecks, there are no single points of failure, and there's much more censorship resistant. And that is really, I think we'll go through each one of these at a time to show why we think each one of these is compelling. But first, peer-to-peer can scale. Decentralized open architecture, it allows the addition of limitless resources effectively on demand. And so it's sort of when there's a shortage, pricing goes up, resources are added. That's just sort of economics 101. And we can see the global community can respond far faster to a resource need than any particular company can. And that is what open peer-to-peer networks take advantage of, is a global community and global availability of both hardware, which is sort of the obvious one in terms of network resources, but also in terms of software, which I'm going to talk about as well. But the point is both of those can respond to demand needs much more quickly than any centralized business can. And also, it leads users that have different needs for different reliability to choose the level they'd like to pay for. And that's also kind of an important element, that not every user needs the same level of reliability or wants to pay the same pricing. And in terms of security, open peer-to-peer networks are also far more censorship resistant, because anyone can author or host an application. And if code is running on an open peer-to-peer network, then you've got no legal entity to sanction, no board of directors to compel, no employees you can find to drag in or threaten with jail, and no shareholders to really pressure. And so when you have an open protocol that on a peer-to-peer network on which an open decentralized application or a DAO is running, you really have a massive censorship or massive benefit of censorship resistance, given the distributed nature of both the code, the hardware, and the actual human talent behind it. And you need all three of those things in order for things to work in a way that will actually resist some of the obvious interference that we've seen. And then in terms of network resilience, you have applications that live in the network, and they can be hosted in different geographies, by different providers, by different clouds. They can move very easily, and if any host would like to host an application, they can do so. Right now, there's great benefit to this. There's also risk to it, right? There are applications I'm sure none of us would like to see that could exist more easily in this type of a world. And so there's also risk with this, which we have to be aware of. And we don't have yet obvious solutions for that, but that is something I just have to call out, that it's not purely positive to have an open permissionless peer-to-peer system, because you can have things that we don't want, right? And so this is a trade-off that we're all going to have to face. And unfortunately, I don't have the answers for it, but I think that we're shifting right now towards so much centralization and so much censorship that we probably err a little bit on the other. It's going to go the other way, hopefully, for a while, and we'll figure out kind of where that middle place should be. But peer-to-peer platforms right now lack the compute layer. And so peer-to-peer requires three things to be a fully functioning ecosystem. You need payments, you need storage, and you need compute, right? And so we know that two of those exist and are working very well. But the compute layer allows the off-chain scalable computation, without which you're very limited in what you can do. And so let's talk about open peer-to-peer traction. Everybody knows the traction of crypto, right? Crypto started all of this, payments. And whether it's Bitcoin, whether it's Ethereum, whether it's, name your coin of choice, that is working, it's functioning, it's global. That has been solved largely. Storage, thanks to IPFS and Filecoin, is also seems to be solved, and only getting more and more solved based on the presentations that I just heard today, which is fabulous, right? You have recall is much faster, storage is only increasing dramatically, huge amount of storage on it, and I think that's only going to increase. But compute has been a hole so far, and you need compute to have fully decentralized applications. And so let's look at where compute is now. You have smart contracts on chain, and that's compute, right? But you're limited. It's deterministic, right? And so you're constrained both by what you can compute and by cost as well, and by speed. And then you have decentralized hardware marketplaces. And that's fine, but those also are generally managed on-chain, and that is about sort of more renting hardware, and it's not actually about offering the computation services. So it's sort of a layer below the actual clear compute that applications need. So what's missing? You want to eliminate entrance barriers, and you want sort of function addressable storage and the ability to run full-featured backends, and basically also, if you want, be pluggable to blockchains if you want to have consensus as part of your compute. And so you basically need to have general purpose peer-to-peer compute. And that's what Fluence is working on. And it's any computation is supported, and it's function addressable, permissionless, with a universal runtime. And so that's what we're building, and whether it's us that are successful with it or others, we think that is a critical component of making Web3 a fully functional and featured solution. You know, we talk about where else this can be used. You know, one element here is deplatforming, and I kind of referenced it earlier, but you need to have this ability of computation distributed in order to avoid deplatforming. And we've seen that happen in the Web 2 space, right? You've seen Twitter kill off a bunch of features. You've seen Facebook deplatform. I'm dating myself, obviously, but Farmville way back when. And so you've seen deplatforming happen both from an application level. You've seen it Parler on a company sort of level. You've seen deplatforming happen across the space. And the idea is to create an architecture that prevents deplatforming. And that is what we're focusing on. The area people haven't focused on so much is deplatforming still is a risk even in Web 3. And that's because there's still centralized developer APIs with a lot of the Web 3 businesses and Web 3 applications that we know very well. And this hasn't happened yet. We've run some risks of it, but this is still an issue. You also have centralized backends for very well-known and important Web 3 businesses, right? And so this is not a critique of these businesses. There aren't real alternatives right now. And that's what we are trying to provide, others are trying to provide, because to be fully functional Web 3, you can't rely on centralized developer APIs. You can't have centralized backends just to serve a decentralized user interface, right? So you have to get a step deeper and have this compute layer fully functional and live. And so how do we build these best peer-to-peer applications? And in this community, I think people will appreciate it, but it doesn't have to be blockchain-based, all right? People here understand that storage is not all on-chain, right? The incentives are on-chain, and the verifications are on-chain, but the storage doesn't have to be. And so compute also doesn't have to be on-chain, and if it is on-chain, you run into a variety of constraints. And so also, let's not forget, the current hugely successful cloud businesses, their compute is not on-chain, and they're doing just fine with a huge number of very important, significant customers who pay them a lot of money. And so we like to look at it this way, where you have centralized computing and on-chain computing, and in the middle is where Fluence exists and where we think peer-to-peer computing exists, where you have no middlemen, you don't have the redundancy you do of blockchain-based computing, but it is verifiable, you can plug in consensus, and you can anchor on-chain. It's far cheaper and far faster than on-chain computing, and it's not deterministic. And so I think in this group, I probably have to spend less time on that, given your familiarity with IPFS and Filecoin and how that storage and verification works. But it is important that people sometimes equate peer-to-peer with on-chain. And all I have to do is go back to the Napster days to realize, right, that doesn't have to be the case, and started off, frankly, not being the case. So what is Fluence? It's a peer-to-peer application platform. And so it's a computing network of nodes. It is a programming language that is the first programming language for native peer-to-peer application composition. And then that allows basically a code creator economy I'll talk about, because I think that kind of it gets to some of the resilience I was referencing earlier. But what this application language does, which is called Aqua, it basically allows functions to exist and to run without central coordination. And so you can create a function that looks up the next, basically looks up the location for the computation to be performed, completes it, and then looks up the next peer to perform the computation, and then continues. And it's very different than the client server or the client server type of computation. And that is a terrific innovation. And basically the application construction in Aqua allows you to create these the applications much faster than if you were to try to, for example, use Rust, which we think is kind of the closest peer to it. It's based on PyCalculus, and it basically views applications as network protocols. And I'm going to skip through some of this because we're running a little bit out of time, but you can see what's available now, which is peer discovery. Obviously there's DHT, which is an important part of this, as critical in any functioning kind of network. File management, data stream, et cetera, and a whole number of things are on our roadmap to come out later this year. But effectively, you run peer-to-peer computing network runs Aqua, which allows you to have high throughput, permissionless, and effectively unstoppable. But there's no global consensus, and that's a positive because you're not burdened with the consensus overhead. And this is, I think, really important. So if you think about how software and code has been developed so far, you look at this as version 1, version 1.1, version 1.2. And the author or company creates version 1.0, it discontinues it, you move to version 1.2, it discontinues it, and then you can see all the hosts are hosting version 1.2. We're kind of comfortable, and that's what normally happens. But if you're running a peer-to-peer network, and the Fluence architecture allows this, you basically, when an author puts version 1 out there, it's out there. And as long as a host has a customer that wants to pay for that version 1 code, it's there. If the author wants to change it, he can't. It's already out there, right? The author can post version 1.1, host can host that. Author can create version 1.2, host can host that. But there is no you're pulled out of as a developer. You're pulled out of that upgrade cycle, and your dependencies are safe because you're not compelled to continually upgrade, unsure of what might break or what other changes you might have to make. And so this basically releases code and allows it to exist based on the market as long as people want to do it. It also prevents disgruntled developers from inserting malicious code into existing kind of applications, which we've seen happen as well. And so what that basically, and just to go back on this, the way we've architected this is code is hosted. The host shares a small amount of that revenue with the author. And so some developer using the code will pay a hosting fee just like you do on any other platform, Amazon or whoever, but some piece of that via smart contract goes to the original author. And so it's actually an ecosystem. This is the code creator economy concept that actually will allow open source developers to issue code, have it work, and actually have some revenue associated for that for as long as that code continues to be served. And so I kind of mentioned this, that nodes are that basically you're sort of no longer out of that upgrade cycle as a user, and as a developer you benefit from anyone using it. And so where are we right now? We've launched the Aqua and the peer-to-peer network. It's live. You can look at it currently. We're working on launching a DAO that will happen this year to govern our network. And then the compute economy, which is effectively that smart contract-based relationship between the code that is created and the host that hosts it. That is the element that we're working on next and should be out later this year as well. So, find us here at our developer hub, dash.fluence.dev. I guess I'd also say that here's some other elements, the Fluence.network, our Discord as well. And I guess I just say, this is sort of rhetorical for everybody here, but I don't think any of us want 3 companies controlling internet hosting. And I don't think we want our content monitored by nation states, right? And so right now, there are really high barriers to building independently, not on these 3 companies. And Fluence is trying to build a world and a network and an environment that makes it easier and simpler, and we hope even better, to create and build outside of all of these ecosystems, and in an ecosystem governed by and that rewards the whole developer community globally. And that is our vision. And so I just say here to support Web3, host, contribute, follow, and we're super excited to be working as closely with IPFS and Filecoin as we can to help enable that world that I think we all believe in. And so with that, I thank you for your time and attention, and happy to take a few questions. Do we question, or I go over to any or no questions? Yes.
So are there any plans on the kind of hardware that would be needed to be like a compute node?
So it's that we're working on that right now. So we have nodes up currently, and so let me phrase it this way. It's going to be more about reliability than power, and right. So it's not like Bitcoin. It's not like mining. It's more about the computation level you want to provide, and then your cost of providing that versus the cost of other people providing it. So I think it's going to be more about what people will value. I think is going to be more about reliability than raw computation power. We don't think of Fluence as being ideal for like sequencing a genome or something like that. It's not about raw power, but it is about, we think people will care more about reliability. So bandwidth uptime, network uptime, et cetera. And I think that's going to be more of a focus than raw power. Anything else? Okay. Thank you guys. Oh, yep. Oh, sorry. Yeah. I mean, listen, the answer is no, but machine learning is like saying that there's so many different kinds, so I don't know. And the other point I should mention is also we've seen people want to run Fluence nodes internally on their own systems as well. So right now, what people are doing on Fluence is actually using their own hardware to run applications and to develop on top of it. And so I think that we could see that happen internally. I don't know whether you will use it to have, so from that side, yes. I don't think you will see people say, let me get 6 different hosts around the world and together kind of run a machine learning application. I doubt that, but will someone either do it in-house, maybe, or will someone find one host that has sufficient kind of both bandwidth and computation to do it? Possibly. But it's not a, let's find, spare laptop capacity around the world and pull that all together. We don't think that's the realistic use. And we've got breakfast tomorrow at 9 if anybody wants to meet more of the team, and our decentralized summit tomorrow at the Vox Hotel. So we're on the main. Oh, sorry, Metropolitan. My bad. But we should just look at the general schedule, and we're on it. All right, for DevConnect. Thanks everybody. Appreciate it.
Mobile technology has made the world increasingly interconnected, benefiting nearly everyone. When one nation experiences a crisis, every nation feels the impact. And while surveillance may be targeted to specific individuals or groups, the privacy and freedom of many others may be inadvertently impacted. But imagine having the ability to fully communicate in any nation, in any situation, with or without internet access, and without worrying about your communications being monitored or shut down. I'm Manfred Tourne, and as you can hear, I'm French. I'm a cybersecurity engineer, and 3 years ago I founded Bertie Technologies to defend citizens against censorship and surveillance. Bertie is a tech non-profit organization, and everything we do is free for all and open source. The project was born in Paris because the core team was composed of French engineers. We are now distributed, and the community is growing worldwide. We are a core team of 10 persons, and everything is done all around the world by and for the community.
The problem is that a lot of mainstream applications are owned by big companies, and they store their users' data on their server. They are making money by analyzing this data and selling it. That's why a project like Bertie is born and must exist. When you send a message to a friend, you are actually sending a message to a central server, which will forward the message to your friend. In some cases, the messages are encrypted, so only you and your friends have the key. In this case, the server can't read the messages, but it's not totally safe yet, because the server still knows who sends messages, who receives them, at what time and at what quantity. We call that metadata.
Ex-NSA chief told that they were killing people using this metadata. Bertie allows its users to control their communication and to contact their friends directly.
Unlike most of the other messaging apps, Bertie is decentralized, which means there is no central server to spy on, to hack, or to shut down. Instead, Bertie users will directly connect to each other to send, receive, and relay messages.
Even us, as founders or developers, cannot access to anything. The data is stored on the local phone, and they can send messages to their friends through or without intermediaries. That can be a friend's phone, a colleague server. For example, if you run Bertie with your friends in a plane, you won't have internet access, but you will create an autonomous local network, like a mesh network with your friends, using proximity drivers like Bluetooth or local Wi-Fi. When using the Web 2 approach, you depend on a specific infrastructure, and as soon as one node in the path is broken, you cannot access to the service. Web 3 brings you multiple ways to contact something, so if one path is broken, you can still try to use another one.
IPFS make everything we do possible. We use it as a peer-to-peer network layer for our messaging app. In this configuration, Bertie takes care of all the identity mechanism and the encryption of messages. OrbitDB allows us to store data on a peer-to-peer network like with a traditional database, when IPFS distributes all the data between users. Its modular design allows us to adapt it to the mobile platform, then to extend it with our Bluetooth feature.
Our mantra is steal this code. We want hackers and developers to use the Bertie protocol. The Bertie protocol is a gift to allow anyone to create a Web3 application easily. There shouldn't be a business model on privacy. Bertie is a gold standard for the decentralized secure messaging, and the ability to communicate even without an internet connection is out of this world. Literally, in theory, you should be able to use Bertie chat even on Mars. I can't imagine the future without Web3, and I can't imagine stopping the Web3 development. So I'm pretty happy to participate to the Web3 adventure. In the future, it cannot be stopped.
All right, hi everybody. Can you hear me? Yes. Okay, so we are actually running a little bit ahead of schedule. All of our speakers were so prompt and on time. So we're going to start the lightning talk session now. We have, if either Ryan Shaheen, if you're here, or Khan with Ethereum, if either of you guys are ready to do a talk. Otherwise, anyone else, please let us know if you'd like to come up and tell us about your project, how you're using IPFS. Do we have Ryan or Khan? They're here, I know. I saw them earlier, but.
Okay, well, how about we take a quick break? Everybody can get some refreshments. We'll come back at 5:15 is when we're actually going to start the lightning talks, okay? Grab some coffee, something to eat, come back, and we'll see you in a few minutes. Thank you. Hi, everybody. Welcome back from the break. We have some lightning talks lined up. So first, to get us started, we have Ryan Shaheen from Portrait. Ryan, here you go.
All right. Just waiting for the, there we go. How's everyone doing? Pretty good. How's everyone doing? Ooh, right, all right. So I'm Ryan from Portrait, and at Portrait we turn blockchain addresses into beautiful websites. What does it mean? Portrait is the first open source, so another one, yeah, open source! Yeah! So it's the first open source servers that bridges the gap between blockchain domains and distributed file hosting, so read IPFS. And why is this needed? So what are blockchain domains? For those who don't know, blockchain domains turn a complex string of characters into a human-readable format. Owners of blockchain domains can set DNS records and point to a website, preferably their own. So what we're looking at is really a layer of improving the UX of Web3. But although ownership of blockchain domains may be publicly verified on-chain, the integrity of the ownership of a website set through the DNS records may not be verified. So what does that mean? Let's go for an example. Vitalik. Vitalik may set the DNS records of vitalik.eth to his Medium page. And the following issues may arise. Medium may go offline, temporarily or forever. Thus, we cannot guarantee data persistence. Additionally, Medium can change the posts written by Vitalik, and we may not verify the authenticity of his blog post. Another one, Vitalik's Medium account may get compromised. A hacker may access Vitalik's Medium account and write malicious posts on behalf of Vitalik. Another one, censorship. Medium can delete Vitalik's posts. And some of these issues, such as mitigating censorship, can be fixed by using IPFS. However, there's no way of deriving the Ethereum address of the creator, which is Vitalik in this example, in a user-friendly way. And that's what Portrait is aiming to fix. So Portrait provides a layer of cryptographic proofs by generating proofs over entire web pages before pinning them to IPFS Filecoin. Portrait web pages contain tamper-proof signatures of ownership and edit history. Additionally, thanks to the guys over at Estuary, we can provide this service for free. So if you're building a website with Portrait, it's free for a year. And so this is our first talk, and we are very proud to showcase some UIs that are in the work right now. This is a UI, so when your portrait is empty, you can add blocks to it. So it's really a website builder. But on top of that, there are proofs which verifies the ownership of a blockchain domain. So these front-end designs have been designed by Gilliam in the corner. He's my co-founder. So our beta program is live right now. You may sign up at portrait.gg. Also follow us on Twitter, and we're also at Filecoin and Friends after this. So if you have any questions, feel free to hit us up. That's it. All right. Any questions? One question in the back.
Is there a verification stack for the proofs that's like an extension that you Is there a verification stack for the website proofs that's like JavaScript that runs in the browser, an extension? Do you still planning that out? I'm just sort of curious how you get verified as a user.
So the way we are generating the proofs is by leveraging message signing, Ethereum message signing, because we're bridging Ethereum addresses with blockchain domains. So we're really leveraging that, and then we are injecting those proofs into the body of the HTML not directly in the body, but into the HTML file, which is then pinned to Filecoin. So there's a way to derive the signature of an entire website you've designed yourself by just looking, well, you could look into the source code, but we're providing a user-friendly layer to showcase that. Okay. Any other questions? All right. Thank you very much for your time.
Okay, everyone. Thank you so much, Ryan. That was. Okay, great. Thank you. So up next, we have Kaan Uzdagan with Sourcify to tell us all about his project and how he's using IPFS. Here you go.
Thank you. So hi everyone, I'm Kaan. I'm working for the Ethereum Foundation with the Solidity team, and I'm working on the Sourcify project. And we have a public repository of over 1 million verified Solidity contracts. So what is Sourcify in short? We are an open source Solidity source code verification tool, first of all. We also have a public decentralized repository of contract source files, as well as contract metadata. And we pin the metadata and source files of verified contracts. Our goals are overall more transparency in the ecosystem through through contract verification, decentralization of the source codes, as well as enabling human-friendly contract interactions. So before everything, I have to give a short introduction about the Solidity contract metadata for those who are not familiar with it. The contract metadata is the output of the Solidity compiler, and it contains the compilation information, source file information, ABI, and developer and user documentation of the compiled contracts. It looks like this. It is a JSON file with several information. And the nice thing about how we use the metadata with IPFS is that the IPFS hash of the metadata is appended at the end of the bytecode. So this IPFS hash of this file is appended on the on-chain bytecode at this field with several other information. And the decoding of this information can be shown like this. If you want to, I won't be giving into detail, but it's a CBOR encoded information that you can play around with these at this playground if you want to learn more how this is done. So how do we use the metadata? What at the end of the day your wallet can do is get the contract bytecode of the contract you are interacting with, the on-chain bytecode. Then it will decode the hash of its metadata and fetch the metadata from IPFS. And then it will decode the contract call you are doing at that moment with the ABI and the user doc, which is already found in the metadata file. So it's in the output and the docs section of the metadata. So at the end of the day, what we want to achieve is something like this. So we want to show users, or at least the wallets to show users, instead of an information on the left, like hex strings, instead of human readable information through ABI decoding and documentation. Also, what you can do is you can fetch the source files with their IPFS hashes, because the IPFS hashes of the source files are also embedded in the metadata. Our repository contains all these metadata files and source files, and it's served over HTTP and IPFS. Right now, we have over 1 million small files, consisting of the Solidity files and the metadata files, and overall it's around 11 gigabytes right now. We also serve the repo under an IPNS, which is updated regularly. Currently, the update schedule is every 6 hours, and our repo is structured as follows. We have the contracts, we have the full match and partial match types, because we have in Sourcify we have 2 matches. Also, we have the chain ID, because Sourcify supports most of the EVM-based networks, and their contracts can be accessed with chain IDs. And at the end of the day, you have the contract address. So you can check out the repository through this link, or you can visit our website and find the contract repository link in the footer. So, thank you. You can visit our website, join our discussion, and I'll be happy to answer your questions. Yes, Boris.
How can we help?
Thank you. Great question. So we are trying to reach more developers, and first of all, contract developers, and as well as the wallet developers. As a contract developer, what you can do is publish your source files and metadata when you are deploying a contract, and also use the NatSpec commands. I unfortunately don't have any slides for that, but NatSpec commands are basically the standardized comments of Solidity using user documentation and developer documentation parameters. So when you add them to your contracts over your function, so if you comment on your functions, when your users call the function, we can show the detailed information about the function. So when, for example, when your users are calling a function called transfer, you can show transfers X many tokens to this address by dynamically filling the fields. And so that's what you can do as the contract developer, and as wallet developer, just please reach us out and think about integrating Sourcify, making use of these all verified sources, and spread the word for Sourcify verification. Yes, please.
So is there
I think there will be the microphone.
So is there like an API that integrates to upload the verification, so that we could integrate either on plugins or like hardware or something like that?
So we have an open API that you can check out the docs. The API has, like through the API, you can give us the source files and the metadata. So we will recompile the whole thing and check and compare with the on-chain bytecode, as well as we have several integrations. For example, the Hardhat deploy plugin. So when you compile with Hardhat and when you deploy with the Hardhat plugin, you can just say deploy Sourcify mainnet, and it will verify the file as well. Also, we have another plugin for Remix. In the Remix also, when you compile and deploy the contract, you can directly use Sourcify verification. But obviously, we need more integrations and to integrate the verification in the development pipeline.
Since which Solidity version this metadata hash is appended?
If I'm not mistaken, it should be like 0.48, something around that. Before that, it was not appended. And before that, we were using Swarm, but then IPFS is added, and IPFS has become the de facto standard for metadata hashes. So if there's no questions, thank you.
We're just going to get our next presenter lined up, and then we'll start in just a moment.
How many? And we're starting on integrating this with chain auth. So any blockchain should be able to just log in with your regular chain identity and use that as the index to store user files in any browser, including on native mobile, so that all of your files are both public and private directly on IPFS. My team here as well, Brooke, who's the inventor and chief architect of many of these things, Ryan, who wants to talk to you about wallet integration, and Stephen, who's a primary author of any of these things. Thanks everyone for coming. So happy to have the IPFS and Filecoin community here. Let's build awesome edge apps. Any question, and can I sell you a car to go with this fantastic pitch? Fantastic. Come see me later. Thank you very much.
One of the things that we realized when building Web3 tooling is that we're still distributing all of our tools over Web 2. Distributing software with Web 2 infrastructure inherently relies on single points of failure. So even though you can build a lot of security around your build servers, it's still vulnerable to attack. I'm Alec Wantock, co-founder and CEO of Valis.
My name is Zachary Pelkey, and I am the CTO of Valis.
I'm based in Harrisburg because this is where I went to university and ultimately met my co-founder, Zach. We both had a couple remote jobs, and when entering Web3, we realized that we didn't need to go to any major hub to do what we needed to do.
What led up to Valis over the years, all of these problems that we had seen with releasing software and distributing your software, we wanted to kind of use these next generation technologies to make developers' lives easier so that they don't have to really deal with these problems anymore.
With the SolarWinds attack, the whole world saw what happens when everyone relies on a single point of failure. And when attackers are able to get behind a single system that everyone's relying on, hackers were able to bypass their access control systems, make themselves administrators, and issue malware as if it was genuine software. And since everyone was relying on SolarWinds security, it quickly broke down once they got access.
With Valis, we could have almost completely eliminated the situation.
We use cryptographic key pairs for our authentication mechanism. So there's no usernames or passwords. If there is a database, it will get breached. So we eliminate that entirely from the picture. we've built a system that makes it really easy to rotate developer keys, as well as the keys on your build servers.
As a developer, I have a private key that I have not shared with anyone else in the world. And using that private key, I can then sign a piece of data, which then produces a digital signature. And then using that digital signature, anyone from all around the world can then take my public key and they can verify that I am the signer of that piece of data.
Valist's mission is to accelerate the transition to Web3. We're building the railings to fulfill that vision so that we can have Web3 native applications from source code all the way to the end application. Valist actually couldn't exist without IPFS. IPFS is our primary storage layer, and it comes with a lot of security guarantees out of the box. We take the content identifiers or the content addresses from IPFS, and then we coordinate which of those belongs to a particular version, like 1.0.1, for example. Once we have that coordination, then the entire network can deliver that specific piece of software to wherever you need it to go in a secure way. Valist is a strong access control system applied to decentralized storage. And what this allows you to do is distribute almost any software, from executable binaries, NPM packages, to Docker images, you name it. And it allows regions to transfer their dependencies between each other very quickly, as well as other developers. You could create a verifiable, cryptographically provable link between your source code and the end application delivered to your users.
With traditional Web 2, there's not really any guarantee that my artifact that I have uploaded to a web server will stay online. With something like Filecoin, I now have a geographically diverse set of servers from all around the world. This now takes the process and democratizes it so that anybody, anywhere could take the data on IPFS and back that with their own IPFS network. Not only that, they could now even contribute Filecoin so that that software could live on the internet indefinitely.
In an ideal world, consumers wouldn't even realize that they're using Valist. They would just realize that they're seeing a lot less hacks. And for developers, we've focused really hard on making the onboarding experience seamless with things like passwordless email login, meta transactions. Even if you have no Web3 experience at all, you could get started using this and still use your favorite developer tools. Valist is effectively the railings that we need to fully realize the vision of Web3 and allow us to distribute all software in a peer-to-peer way.
Web3 is inevitable. Through decentralization, we're all coming together from all over the world to make the internet a better, stronger, more resilient place against hackers. Join the revolution.